I am Dr. A T Ravichandran, Associate Professor of Physics. Okay, good morning, students. Today we are going to discuss about the theory of practicals for the experiment calibration of high range voltmeter using a potentiometer. So this experiment consists of two parts. The first part is this one. So this is the primary circuit and this one is the secondary circuit. In the primary circuit, the potentiometer AB is the potentiometer, which is a 10-meter wire which is connected to a 2-volt battery and a tap key. So this is known as the primary circuit. And the secondary circuit, we have connected a Daniel cell of voltage 1.08 voltage and a high resistance and a galvanometer to a jockey. So the position of the jockey is adjusted such that we have got the balancing length, and it is noted as L1 is equal to dash meters. And in the second part of the experiment, the primary circuit is kept as it is, whereas the secondary circuit is replaced by this one. Here this experiment is used to calibrate the high range voltmeter. So a high range power supply is connected, which is connected to a two resistance R1 and R2. This can be called as a resistance divider network, so that it can be connected to this through a tap key and a rheostat, and a voltmeter is connected. And the first experiment, the Leclanche cell is replaced and we have introduced the secondary circuit. As usual, we are having the high resistance and galvanometer. So here what we have to do is, we have to adjust the rheostat and set down the voltage, and for the particular voltage we have to find out the balancing length. Say for example 1 volt, find out the balancing length, it is known as L2, and adjust the rheostat, make it as 1.25 volt, and again adjust the find the balancing length and note down the value as L2. So balancing length will give null deflection. So we have to enter all the details in the tabulation. So this is the tabulation where voltmeter reading, balancing length L2 in meters, and the calculated voltage. The voltage is calculated by using the formula V dash is equal to 50 into 1.08 L2 by L1, where R1 is the resistance which is having 20 ohms and R2 9800 ohms. This resistor divider network gives the value 50. So from this tabulation, we have to draw two graphs. Graph 1, taking the voltage in the x-axis and the calculator in the y-axis, we have to note down the points and we have to draw a graph. And in the second graph, taking voltage in the x-axis and the correction in the y-axis, and we have to note down the points and draw the graph. So these are the theoretical part of the experiment, calibration of high range voltmeter, and now we are going to the lab to see the actual setup. Students, in the first part we have discussed about the circuit diagram and the tabulation. Now we are going to discuss about the actual experiment. So this is the potentiometer A and B. So this potentiometer wire consists of 10 meters. So a 2-volt battery, the positive terminal is connected to the point A and through a tap key, and the negative is connected to the potentiometer point B. This is the primary circuit, and this is the secondary circuit where we have connected a 1.08 volt. The positive of this 1.0 volt battery is connected to the point A, and negative is connected to a high resistance and to the galvanometer, and the galvanometer is connected to the jockey. So this is the first part. This is the first part of the experiment. To check this experiment, we have to see about the functioning of the galvanometer. So if you place if you place the jockey at point A, the galvanometer shows the deflection in the left hand side, and if you press at point P, the galvanometer shows a deflection in the opposite direction, which shows the circuit is correct. So now we have to find out from where we have got the null deflection. So A, B, wire 1, 2, 3, 4, 5, 6. So there is a balancing point between the wire 5 and 6, and we have to identify the balancing length by moving the by sliding the jockey, and we have to find out the balancing length 1, which means there will not be any deflection in the galvanometer. So, this is the balancing length for this. So, this is 5.78 meters. So, this is L1. So, this is the part 1, and now we are going to the part 2. The part 2 we have to replace this 1.08 battery by using a secondary circuit. So, here we are going to measure the voltage of this high tension battery. So, nearly we can measure the voltage in the range of 100 by using this potentiometer. Here we are using a potential divider arrangement. This is a 4 dial box R1, this is another 4 dial box R2. R1 and R2 are fixed in such a way that these two values are equal to 10,000 ohms. So, these two are connected serially, and these two are connected to the high tension power supply through a rheostat and a tap key. A voltmeter is connected across the two resistances, and we have to change this circuit only. So, instead of this 1.08 voltage power supply, we are going to connect the secondary circuit like this. Now, we have constructed the secondary circuit to measure the high tension to calibrate the given high range voltmeter. So, now we have to adjust the rheostat so that the voltmeter shows 1 volt. So, we have to repeat the experiment as in the first case. The left side, the deflection goes at point A, the deflection goes to left side, and point B, the deflection goes to right side. So, again the circuit is correct. So, we have to find out the balancing length where there is no deviation, there is no deflection in the galvanometer. So, it can be called as L2, and again the experiment can be repeated by changing the rheostat. So, the voltmeter reading can be changed. So, for each and every voltmeter reading, we have to find out the balancing length L2, and we have to tabulate the reading. And as you have seen the tabulation, we have calculated voltage will be obtained by using the formula, and we can draw two graphs. One is the voltage versus the correction, second one is the voltage versus the calculated voltage. So, from this experiment, we can measure the high tension voltage by using a simple apparatus, the potentiometer. Thank you.